You're in the middle of building this awesome new feature in your game. All you need is just to find that one scene file you made a while ago, and it's gone. This is just one example of how poor organization of your Godot project can cause a lot of headache if treated as an afterthought. Today, I'm going to teach you how you can not only organize your projects better, but help you navigate your ever-growing game. Whether you're working on a small prototype or the next big thing, I got you covered with some cool tools and tips to help you spend less time on finding stuff and more on building stuff. Let me organize my thoughts so we can get started. Let's take a closer look at the project structure from the intro. What makes it poorly organized? Here's a quick unscripted section to better illustrate why. So one of the reasons why this organization structure is bad is because there's really no consistency to it at all. We take a look here, we have an add-ons folder and that looks fine, right? But now we have a loose scene right here. We got a lot of loose assets. And these folders don't make a lot of sense, right? There's just like this arts folder kind of sitting around here. And there's also just like this, these other folders just kind of laying around. There's no organization whatsoever. So if you want to find a scene, good luck trying to find it. I mean, it will be right here, but what about your other things? Like, what about my character? There's still a lot of stuff that I can't find. Like, I can't even find my character. Okay, see, she ended up here. So this does become a pain to manage, but this is an obviously bad organization structure. All this being said, don't feel down if you've done this in your project. The goal here is to understand why organization patterns exist and how you can use the knowledge to save you time down the road. As long as you're more intentional in how you organize, you'll work better. So how do we organize better? Before we can understand how, let's discuss the goals of good organization. To find stuff fast, to work better with teams, and to scale your projects over time. There's a couple of common patterns designed to achieve these with varying degrees of success, so there's no one-size-fits-all solution. However, as we progress, I'll show you what works for my project, as well as other patterns that may help yours. We'll start with organizing by asset type. This pattern groups assets by their type, such as sprites, models, sounds, music, materials, shaders, themes, fonts, and of course, scenes. Typically, all this means is that you'll have top-level folders named after these. This is a great pattern for beginners, as it makes sense to organize your assets by, asset type. Notice how it's much easier to find things now because everything is in its own folder that makes sense, and not overly nested in other folders. There's no nonsense. If you're looking for a model, it'll be in the models folder, and so on. So this pattern gets bonus points for speed. However, if you plan on making your project larger, or you don't know for sure how large your project will become, this structure will not scale super well. Notice how many scripts we have. It's going to get increasingly harder to find the right scripts as this list grows. Therefore, how do we solve this problem? By creating folders including everything each asset uses, we can make the project scale better, but still offer decent searching speed. This pattern will be referred to as organizing by scene. For example, let's say you have a player character. Instead of putting her sprite in the sprites folder, her animations in the animations folder, and her scene in the scenes folder, you just create a folder for that character and place all the assets together, regardless of the asset type. They're all related to the character, right? And only the character uses them? The official Godot documentation recommends this for a reason. Given Godot is scene-based, it makes more sense intuitively for assets to live near their scenes. It's a much more scalable approach that allows you to make any number of entities in your project and still keep it organized. Since everything is also decoupled from shared folders, it makes it easier to work independently on individual assets without breaking things. However, there's a small problem. What if you have a lot of entities? Say, you have 10 playable characters, hundreds of enemies, and hundreds of levels. In my game, I'll have multiple systems too, such as a combat system, a menu system, and a progression system. Even with this organization strategy, it'll still run into its upper limits on scale. The good news is that there's a pattern we can use that gets the benefits of the scene-based organization, but also allows us to keep shared assets and scales with your project much better. The structure I'm about to show puts what we learned together into one cohesive pattern. This is what I call the entity system pattern. You'll start with two main folders, the Entities folder and the Systems folder. The Entities folder works like the by scene approach, but grouped by type, characters, weapons, effects, enemies, etc., with subfolders for specific assets. The systems folder is for your core game logic, organized by function. For example, a combat folder could hold battle UI, damage counters, and combat scripts. It's similar to the by scene approach as well, but related functions are nested. Based on my research, this is commonplace in large AAA projects as it optimizes the decoupling of all the resources in your project, meaning they can be used as independently as possible. When working with many people, such as artists and animators, they can now freely create entity folders whenever they make new characters, or they can seamlessly update older ones, since they are so self-contained. This also makes it easier for other developers to work on the menu system while you're churning out the combat system. To handle assets you would share across your entities and systems, you can create a shared folder, where you could put pretty much anything that doesn't belong directly to one of your entities or systems. Here, you're more flexible with making the folders by asset type, as they'll be more sparse than if you organized your whole project that way. Of course, if you ever feel it gets unwieldy, you can add more folders in here too. While this organization pattern scales the best and enables your team the best, it takes a bit of a learning curve to find things fast. So it won't be for every project, but keep in mind that this sets you up for the most success if you want to make a big game. The good news is that these problems can be mitigated, and I'll show you how in a bit. But before we do, we need to discuss how to name things. They say in programming, the two hardest things are cache invalidation and naming things. The good news here is that we're not talking about cache invalidation in this video, so don't worry about what that means. The bad news is that we have to talk about the next hardest thing. There's a couple of rules that Godot itself recommends at a basic level. First of all, Godot recommends using snakecase on your folder and file names. This includes scenes, models, sprites, scripts, you name it. The main reason for this, besides being Python-like, is that operating systems have varying degrees of case sensitivity, and consistently naming folders in all lowercase helps ensure your stuff works well on any OS. The second rule is naming nodes within a scene with Pascal case. This is just so your nodes match the naming convention used on built-in nodes. The exception, of course, is C# scripts, if you use it in your project, as those need to be in Pascal case. Okay, great. We've covered the Godot stuff, but how do we name things ourselves? This may sound like a cop-out, but the best answer I can give is to be consistent. Remember my arts folder? Yeah, I know I'm breaking the lowercase naming convention, but since these represent codes that I know well through a spreadsheet, I'm not as worried about this. All attacks start with ATK, all skill arts start with SKL, and so on and so forth. But it's up to me to keep that convention going. The same is true for your other assets. Just try not to mix cases too much, and you'll be alright. Now that we got a little background on naming things, I can now show you my game's project structure and explain a bit more on how I made certain decisions. This section is unscripted, so feel free to fast forward through it or skip it as well, whatever helps you learn the best. So this is the organization structure of my project so far. If you're new to this channel, my project is a turn-based action hybrid RPG with some other RPG elements, such as just like an upgrade system, cutscenes, towns, etc. So the goal of my structure is to support a very large project, a scaling project. Now, your game may not necessarily need to scale quite as much, but this is the example of what I'm doing and why certain things are where they are. So if we take a quick look, let's start with the add-ons folder. The add-ons folder is quite simply just where you would download your third-party add-ons. Godot actually recommends it this way. And this is where I put things such as like the unit testing framework, the old jiggle bones, etc., etc. So this is what the add-ons folder is for. The builds folder is designed just for where I will put my exported game builds. Now, here's the bread and butter, the entities folder. The entities folder contains basically anything that could be considered an entity in your project, be it an attack, such as what I call arts. It could be a passive, like an attribute. Characters, such as Kyla, as you know her well. Could be enemies, it could even be trees. The idea here is that anything that can scale or can have multiples is probably best to go in the entities folder. For example, I would have multiple characters, I would have multiple arts, I'd have multiple attributes. Now, if we look at an art, for example, such as the shine attack that you may have seen in some of my community posts, This contains a scene as well as a data block, which is a resource. If you look here, this is what that would look like. The goal here is that these two things are tightly coupled and they operate with each other so that they are contained in their own folder. Now, as far as naming, I could probably name these slightly better, but given that I use these in my spreadsheets, I'm okay with keeping it as a code, such as this. For a character like Kyla, I have her base scene, which is inherited from the 3D model GLB imported scene. And I would add anything here that is for the model that would be used in any place. So for example, the jiggle bones would belong here. I also have bone attachments for the weapon handles, which even though they're more specific to combat are totally fine here. I could move those around. But the idea is that I would inherit from this scene whenever I want to make like a cutscene version of her or a combat version of her, etc. And speaking of combat, this is the version of her that is used in combat. So there's all the other things like an animation player, just some extra elements such as a user interface. And this is the one that would be used in combat. This, however, will inherit from the systems folder where we talk about that. And then rather than placing her in the battle folder when we get there, we place it here because it is still tightly coupled to the Kyla entity. I think it makes a little bit more sense. You could hypothetically create a folder in your battle system where you just have player and you have characters and you can put them all in there. But I think the purpose of the entity folder makes more sense in this case. So I think just creating a version of the battle scene here and then just doing that for every character we make just makes a little bit more intuitive sense. And of course, just like the 3D model and all that stuff is here too. Now the systems folder is designed to illustrate what kind of game systems you would have. So for example, here's the battle system. And something like the camera here, while this is kind of an entity of its own, belongs in the battle system because it is specific to the battle system. Or at least this version of the camera is. And you can see I just grouped the script and the scene together. So if we look at a camera scene, it's just a camera with a target. And then there is an animation player type thing, spring arm, pivot, etc. So the idea here is this is much more logical. There's more code in here. And this is supposed to describe all the parts of how the battle system would work. You can then use these systems that you define in here to build your entities if you want to do it that way. And then also when we talk about the scene later. To solve the problem of the shared assets, we have a shared folder. Now, the good thing here is, at least in this type of organization, a lot of your assets are going to be bundled with your entities or your systems. So the shared assets folder should be pretty sparse. So for example, I got fonts, materials, and styles, and UI sprites. And then I also have animations, which I could argue I could move into entities as well, which I probably will at some point. But that's the shared system. Scripts could also belong in shared. These aren't really specific to any system in particular, but I have it here just because it is still programmability, and I think it's important here. It doesn't really matter. You could move it into shared folder and it would be just fine. But this is where you would have anything that's not specific to any system or entity in particular. For example, data models. So I'd have a character one here that has stats and such as things like that that represent what a character is. And then you have your editor scripts, your autoload singletons, and like global functions and things like that. Don't worry about what these are right now. Feel free to ask a question and comment if you don't know what an autoload is or anything like that. I'm happy to answer that there. And then lastly is your scenes. So the scenes is where your entities and your systems would come together. So, and here's the battle system, right? So the idea here is that scenes would basically be levels in your game. So I'm going to make probably about like 100 different encounters in my game. So I would make 100 different scenes. And this is kind of like where level designers would go. They would create new levels here, and then they would take the building blocks from the entities and the systems, and they would put them together in a scene like this. Where I have the battle entities, I have the enemies here, the battle camera, and so on and so forth. And then lastly, there's this test folder, but I'm not going to explain that here. That's for a different video. That's for unit testing, which is not something that you necessarily need to do, but it can be helpful and know how to do it. We'll talk about that in a different video. I understand that at this point, we've talked about a lot of basic organizational best practices, but they don't have a whole lot to do with Godot. But I think this next section is a bit more interesting because here we'll take a deeper dive at some Godot-specific tooling that can help you find stuff fast. First, let's look at some keyboard shortcuts. Mastering these makes finding stuff a breeze, regardless of how complex your project organization is. The first shortcut is Ctrl-Shift-O, which is the quick open scene shortcut, meaning you can find any scene just by typing its name. This only works for scene files and scene-like files such as GLTF files, so you'll have to use the next shortcut to find scripts. What's great here is that Godot uses a fuzzy search algorithm, so as long as the characters you typed out belong in a scene's name, they'll show up as a result. It's great if you typoed or if you don't quite remember what you called something. Next, Ctrl-Alt-O is the quick open script shortcut. Just like the other one, you can type the name of the script you're looking for to quickly navigate to it. Then there's Alt-Shift-O, which is the quick open shortcut. Unlike the other two, this accounts for all resources in your project, scripts, scenes, etc. If you don't remember the other two shortcuts, at least remember this one, as you can find anything from here. It just may be more cluttered, so there's still use for the other two. Lastly, Ctrl-Shift-F is the Find in File shortcut, which lets you search text in all your script files. It's handy if you're looking for something specific that you don't quite remember, such as some to-dos you left in your code. And a bonus tip, if you press F1, you can search the documentation of any node type. This can help you immensely while scripting. The second organization trick is using gdignore files. Say you want to keep your raw assets inside your project, such as your Blender blend files or your art files. You can do this without them importing into your game and eating resources. Just create a folder called assets or something similar and place an empty gdignore file inside of it. Godot won't import these, and you have another way to organize your raw assets. These are all useful for organizing your project, but that pales in comparison to what we need to talk about next. Please, please, please use version control. I know game developers who are software engineers are rolling their eyes right now, but for those who got into game development without any formal software engineering training, it's easy to miss this. But it's so valuable that I think it should be done with every project. So what is version control? Version control is a methodology for versioning your code, meaning you can check your project into a repository, which will keep all the change history. Since this repository can be infinitely cloned by yourself and others, anyone with access can grab a local copy, make changes to it, and check their changes into the repository. I know there's a lot of different version control systems, but here I'll show you a simple example on how to use Git through GitHub. And no, they're not the same thing. Note that this isn't a version control tutorial, but rather just a quick demo just to get you started. So to get started with GitHub and Git, you're going to need two tools. So you're going to need GitHub itself, and then you're going to need Git itself. So Git is actually like the engine that drives the Git version control system, whereas GitHub is a repository that holds Git repos. All we're really going to show just here is just how you can get your game code into a GitHub repository. That way you don't lose your data. So first thing you would do is you go to the Git website. Just type Git in Google or whatever, and you'll come up with a website like this. The link's also in the description. Download it for your proper operating system. And then once you have Git installed and configured, go to github.com. That's also in the description. And set up an account. I already have mine, so it should just be pretty straightforward. then what you'll do is you'll come to a page like this. I'm sure you might also have another option right here in the top right. Just go ahead and do new repository, or over here, create new. And then all you're going to do now is just fill out this information here. So I'm just going to call this test repo. And then you can make it private. And then you can leave just the rest as default. Git ignore is a useful tool, but don't worry about that right now. Go ahead and hit create repository. And then to clone your repository, you have a couple of options. You can use GitHub's tool, which is a desktop tool, or you can do one of these other options. So you could use the command line that comes with Git. It's totally fine. But even as an experienced developer, I tend to prefer the user interface versions. Visual Studio Code, if you have that, also has Git integration, which works really well. So you could just download that and use that. It's also a pretty good code editor, and you can also set it up with Godot. Or if you're on Windows, you can use Tortoise Git. It's just a nice, easy shell interface. I'll just show you how to use it using Tortoise Git. So what you do is you just go ahead and clone this HTTPS by copying it. Go into your folder where you want to clone your repository. And then if you have Tortoise Git, it's just going to be git clone. And it's going to be a test repo. And okay. Now all you need to do is copy your game code in here. So let's just take a very simple example here. I have this, we'll just take old Flick code I have here. Go to Git and paste it into your new repository. And then all you do now is you do a git commit. You should have an option with Tortoise Git here. Go ahead and do check all. Or you can go through your files individually, whatever you want. And then just type a message. And then do commit and push. Make sure you also click push, because push will actually push it to the remote repository. Otherwise, it's just going to remain local. Now, if you go back to GitHub and you refresh your page, you have code. So that's all very simple. So another thing you can do is if you wanted to make a change to a file, and I screw it up, right? So it's saved. Git detects that I've made a change here. And then when I go to git commit, I can review that I made the change, and I don't like it. I can revert it. So I could go here and click revert. And it's just that easy. So you don't have to worry about copying your project on your local machine multiple times. You don't have to worry about scrapping the whole thing if you make a mistake. This just makes it super easy to use. So I highly recommend getting into Git. It's very helpful, and it's just worth knowing. And, game development studios use version control. Not all of them use Git. Some of them use more specialized tools like Perforce. But Git is good enough, and I definitely recommend starting with it. We got through a lot in this video, so for those who made it to the end, thank you. The last but very important question to ask is, what if I get it wrong? My answer: don't sweat it. We're not psychic, nor are we divine, so we're going to make mistakes. I assure you, I'm going to have to reorganize my game from time to time as well. What I am saying is that making a change, working on it, and learning that it may not work is just part of the game development process. Therefore, it's perfectly fine to make changes as you go. As a matter of fact, I encourage you, whether by yourself or in a team, to review your code every once in a while and refactor the project so it grows alongside the code base. The goal of this video was to illustrate some options for organization so that you can make more informed decisions on your game. But don't feel like you have to follow these patterns exactly either. You'll find what works for you through trial and error, so it's not anything to be ashamed of. That's pretty much it for this one. Let me know in the comments what kind of organization patterns you use in your projects, and if you ever had any horror stories about missing assets. Thanks again for watching, and I hope you have a great day.